Okay, so the game plan for today is that I'm going to finish talking about the air pollution stuff, but that should only take like 10 minutes or something at most. And then we talk a little bit more about the midterm, so I can go over some of the problems that we didn't get to on Friday. If you have any questions, also feel free to ask. And before I forget, so in terms of what you need to bring, obviously you need like a pencil or a pen. You can write on the exam, so you don't need paper per se, but if you want to bring like a couple sheets of scratch paper or something, that's fine. And then you shouldn't really need a calculator, but if you want to bring a calculator too, that's fine. If you want to bring a calculator, don't ask me if you can like use your phone, like your smartphone as a calculator. Okay, so the other thing I should say is I have some PS2s in case you didn't pick them up on Friday, and I have a couple of printed solutions for problem set 2 in case you didn't get those on Friday, and then I also have a bunch of problem set 1 solutions in case anybody needs those. So feel free to pick those up at the end if you want. Okay, so in terms of air pollution, when we finished on I guess it was like Wednesday now. So we sort of talked about estimates of the effects of air pollution in a bunch of different contexts, and the two main contexts that we've really talked about are, first of all, how air pollution affects infant mortality or infant health in general, and then also how sort of short-term spikes in air pollution affect hospitalizations or even potentially mortality. But I think sort of the question that's really important from a cost-benefit perspective is unfortunately the question that we really have sort of the least evidence on, or the least credible evidence on, and that question is, what is the effect of long-term exposure to air pollution? So what's the effect of living as an adult in an area that has high air pollution for, say, an extra like 10 or 20 years relative to if you lived in an area with lower air pollution? And the problem here is that the type of exposure you're trying to measure here really rules out any sort of diffs and diffs type of study. So the idea behind the differences and differences study is always that you're going to find some sort of sudden change in either like a treatment or a policy or something like that, and then use that sudden change to estimate how the outcome for the treatment group changes relative to the outcome for some control group that you find. But if we're looking at the effect of like a 20-year exposure, then obviously you can't find any short-term change that's going to generate a 20-year exposure. You have to literally wait for 20 years before you would be able to measure the effect on the outcome. So the evidence that we really have to date basically relies on cross-sectional correlations, so essentially looking at what happens when we're looking at the difference in mortality rates for people who live in like high pollution cities versus those who live in low pollution cities for many years on end. And the most famous of these studies is what's known as the 6 city studies by a bunch of epidemiologists. And as you might imagine, it involves looking in 6 cities. Name's very instructive that way. And what it does is it basically follows like about 8,000 adults who live in these 6 cities for almost 15 years. So they actually went, it was part of I think like another sort of study that was looking at something involving cancer or something like that. But they actually went and surveyed like individual people over 15 years. And they got a fair amount of data about them, so they know like what their age is and the genders, smoking habits, education, body mass index, which is like basically weight except it's weight adjusted for height. And so after so they have all these measures, and then they can control for them in regression, essentially. And after they control for these factors in regression, what they find is that the adults who live in the most polluted cities were 26% more likely to die during the 15-year period that they're followed for, relative to adults that were living in the least polluted cities. So the figures, I think, are basically the most compelling part of the paper, in that there's a very clear relationship here, which often you won't actually see if you just plot individual data. But what you have here are basically the mortality rate, or actually the ratio between the mortality rate in the other cities and the mortality rate in the lowest mortality city. That's on the y-axis. And then on the x-axis, you have various pollution measures. So each of these like letters is basically a different city, so there should be 6 letters total. And so you're basically taking the average, well, so the pollution measure, of course, is the average pollution for the city, and then the rate ratio is basically the average mortality rate for people in the study in that city as compared to the mortality rate for the people in the lowest mortality city. And so what you can see here is basically that there does seem to be a very strong upward sloping relationship between the rate ratio and particulate pollution, which is on the x-axis in the first graph, and then there's fine particles, which is a different measure of the particulate pollution in the second graph.
Because it's increasing, you would say that the denominator ratio stays constant. I'm a little confused about the rate ratio.
What the rate ratio is. So it's literally just, so P here, I forget what the names of the cities are, but P has some like mortality rate, like say it's over 15 years, say it's like 10% or something like that, 10% of the people in the study in that city die during the next 15 years. And so then if you have an observation, like say S is about 1.25, so that would imply that the mortality rate in that sample was like 12.5%, or in that city was 12.5% in that during that period relative to, well, it was just 12.5%, and so relative to the mortality rate in city P, it's 25% higher. Does that answer your question? Or? Okay.
Why do you say this question would rule out the different diff?
Why does it? Yes, so that's an important point. So the reason, or it rules out like using a diffs and diff study, because so normally what you would do in a diffs and diff study is like you might see perhaps there's like some policy or some other sort of shock that causes pollution to rise rapidly in say a 1-year period. And so like in the diffs and diff study, what you would want to do is take that policy or take that shock and essentially use it to try to estimate what happens in the city that sees that sharp uptick in pollution relative to some control cities that don't see any uptick in pollution, right? But because it's happening quickly, and because you want to look at what happens in a pretty short period of time, you can't really figure out what the effect of being exposed for an additional, say, 20 years to high pollution levels would be, right? Because you could have a quick change in the pollution level in that city, and you could wait 20 years and see what happens, but you basically have to assume that nothing else is changing between that city and the control city over the next 20 years, which seems like usually that won't be a very plausible assumption. So, I mean, basically what it comes down to is like we like short-term or like very rapid changes, like basically shocks to the thing we're interested in measuring the effect for, so like pollution, because it's sort of credible or believable that other things wouldn't also be changing that quickly to potentially like cause confounding effects. But if you're looking at something that takes 20 years to have an effect, then you can't use like short-term shock.
So the graph here is not supposed to present control.
So that's a very good question. I think it has not. I mean, in principle, there's a way that you can do that and plot it. I think they didn't, but I have to actually go and look in the study to check whether.
What's the rate ratio again?
So the rate ratio is it's basically the ratio in mortality rates between each of the cities and the mortality rate in the lowest pollution city. So for the lowest pollution city, which is city P, or sorry, the lowest, well, it is actually the lowest pollution city, but the lowest mortality city. So that's always 1, right? See, it's 1 there, and it's 1 there. And then if you have, so this guy like H who's 1.25, 1.13 or 1.15, basically means they had a 15% higher mortality rate than the lowest city in that 15-year span. So that's the correlation with particulate pollution. And there's a couple other pollutants that they also have data on, so they look at those as well. So there's sulfur dioxide and sulfur particles, which are on the x-axis of these two graphs. And again, they find pretty much the same sort of upward sloping relationship. And then the final one they look at is ozone. And that one actually isn't so strongly correlated. So see, there's this aerosol acidity measure, which I guess is related to ozone, but I think there's other things that could also potentially cause acidity in the air. So so that one has like something of an upward sloping relationship, though it's not quite as clear as the other figures. And then here, where they actually have ozone, there's basically no relationship at all. The mortality rates are just kind of seem to be pretty much uncorrelated with the ozone levels. Mm-hmm. You mean, would it change the actual like correlation that you're measuring, or would it change your interpretation of it? Yeah, you only have 6 cities. So they did a follow-up one where they have like 100 cities or something, and they find pretty similar results. But the same concerns, though, about whether there might be confounding factors that are correlated with pollution levels here that they can't control for, those concerns still exist regardless of whether they have 6 cities or whether they have 100 cities. So it makes you more confident that like the relationship they're identifying is actually like a population level relationship, but it doesn't necessarily rule out the possibility of omitted variables bias, just because you have a large sample. Yep.
I know that you don't remember the cities, but they have something in common. What are the criteria to select these cities in particular?
Yeah, that's a good question. So I assume it was just that they were in the original study, but then I forget how they when they scaled out to 100 cities, how that worked. Because I thought that in this study, the original purpose of the study was actually not just to look at the relationship between air pollution and mortality, but instead to look at sort of a different question, which actually, I mean, happens a lot in sort of epidemiology and something. Like people collect data for like a heart disease study or something, and then they'll end up using it for something else. Like so I don't know how many people know about this, but there's this like famous, or some might say infamous, study about cure effects in obesity, where this came out like probably 4 or 5 years ago. But there was this paper that was published in the New England Journal of Medicine where they claimed that there were like sort of social network effects in obesity. So like if you have fatter friends, then that makes you fatter, which seems somewhat like questionable. So I would not endorse this study as like identifying a causal effect, although I'm sure the authors of the study would disagree. But the data for that study I think came from like this famous heart disease study that was done several decades ago, or maybe it's still sort of ongoing. But the purpose of that study was to like follow or to try to figure out what things correlate with heart disease. And then these guys just like had the data available and then sort of realized like, oh, we can construct this like social network measure or something of like who knows who, and then use that and like use the BMI data, the body mass index data in there to try to figure out what like obesity cure effects are or something. Which again, I think it's not. I don't think that the research design is very credible there, but it got a lot of press because it's like, if your friends are making you fat, that's something that. Now, I should also say, so not to get too far off topic here, but there has been better research since then done on that question, and specifically it's been done in the population of like you guys, which is to say that, so you remember like our goal is always to try to have like a randomized experiment, and so if you think about what happens in dorms, you actually have like a randomized experiment at a lot of institutions, because a lot of schools will sort of, you fill out like some sort of survey when you come in as freshmen, saying like, these are the types of things or like the types of learning arrangements that I prefer. But then conditional on your survey answers, they basically randomly assign you. Like there'll be some people who kind of are like somewhat compatible with you in terms of roommate selections, and within that group, then they'll randomly pick who they're going to assign you. And so you could theoretically look at what happens to somebody's BMI as a function of like what their roommate's BMI is, to see if there's sort of these spillover effects from like if you get assigned a heavier roommate, does that make you heavier? And if you get assigned a lighter roommate, does that make you lighter? And people have looked at that. I think it's sort of been some mixed results. Like some studies basically found nothing, and then actually the other studies that found something basically found like a negative relationship. So that like if you get assigned a heavier roommate, you actually end up losing weight over the first year. I don't know. So I mean, if they're a positive relationship, you can imagine like, oh, it's like you're picking up some bad habits from your roommate or something, right? The negative relationship, I don't know exactly what's going on there, other than maybe like, you're like, oh, I don't want to, I think that person's overweight and I don't want to like be like that, so maybe I'll avoid it. But so yeah, so that's the sort of better research that's been done in that field, but the conclusions are somewhat mixed in terms of what to actually find it. But as far as I can tell, there haven't been any good studies that have shown that there's in fact a positive like peer effect of having an obese friend or roommate or something on your own obesity. Okay, so that's basically, that kind of summarizes like what the literature is on this long-term exposure. I mean, obviously there's many other papers, but they all kind of come to similar conclusions, and they all basically potentially suffer from the same sort of issues. And so many of the key, the key problem here, the thing that makes it really hard to tell whether or not these correlations represent causal effects, is that they're unobservable characteristics that could affect mortality rates and be correlated with pollution levels across cities. And so it's hard to rule out these omitted variables biases even after controlling for the observed characteristics. And I would say that the search for a clean research design for this question continues. There's one study that came out very recently that's done in China, and what they do is they try to use this policy that, so one of the rivers in China is actually used as a boundary by the Chinese government to determine whether or not people will get city supplied heat or not. So it's basically like if you're to the north of this river, then you get heat that's supplied by the city, and if you're to the south of this river, then you don't get it. And so the idea is like, once you get into regions that are cold enough, it's essential that you have heating. But the city supplied heat is actually super dirty. They basically like burn coal in the central plant, and then they distribute like hot water throughout the city. And so that leads to markedly higher pollution levels above, like to the north of the river than it does to the south of the river. And so the idea is basically they look at cities that are like, maybe within 100 miles to the north of the river, and then compare them to cities that are like 100 miles to the south of the river. And the hope is that on average, these two sets of cities are kind of similar to each other because they're all kind of near the river. But the northern ones have higher pollution levels than the southern ones. And they do seem to find a higher mortality rate in the north than the south, but there's sort of two caveats. One is that it's not that robust, so it's not so clear that there's a huge effect. And the second effect is like, for those of you who've been to China, it's like unbelievably polluted. So, I mean, if you're going to find an effect of like air pollution on mortality anywhere, it's definitely going to be in China. So I don't think, even if you believe that effect, it's not so clear that we would want to take that result and apply it in like the US or in Europe, just because our pollution levels are much lower here. So, like probably the pollution levels here, or even Los Angeles, are probably lower than like even south of the river in China, just because they are growing rapidly and don't really have money to spend on pollution control equipment and so forth. Okay, so that's basically it for air pollution. So, in terms of the midterm. So if you were not here on Friday, the one thing that you should definitely know is if you show up by 4 or 5 or 3 or 5, we'll start then. So I'll give you basically from 3 or 5 until 4 p.m. so you can get a little bit more time than the class normally runs for. I would say, we'll just leave it there. So I would say that a surprising number of people turn it in like before time is up. So historically, it has not been the case that like 80% of the class is still there at 4 or 4:02 or whatever. But usually there'll be like at least 5 or 10 people or something who are working right at the very end. Your mileage metering. Are there any other questions sort of just generally about the midterm? Oh, and then the other thing is, so the Friday after the midterm, which is this coming Friday, I guess the 19th or something, we will not have class. So the next class will then be Monday after. In terms of grading, probably it'll be sometime the following week after that. Okay, so the last time we talked about, the basically empirically based empirical questions in 2010. Now there's also a somewhat different format empirical question in 2011. It could be, in terms of what you guys get on the exam, it could be either of those or both, but I think there's a higher probability that it'll be in the format of the 2011 one, where it's sort of more like short answer rather than these multiple choice ones. The multiple choice ones will definitely show up, but that might not happen until the final. So the last question in 2011 was basically about like a hypothetical study that was trying to measure the effect of the California gasoline blend on air pollution reduction. So like we have this special blend of California gasoline that in theory reduces air pollution. It also means like we use different gas than the rest of the country, and so that means supply shocks can have a bigger effect on our prices, like we're currently experiencing. But the goal is presumably, and the goal of policy is to reduce pollution levels, and so I sort of set up this hypothetical question in which you're trying to measure the effect of the policy by using the fact that it was rolled out in January 2005. It wasn't actually rolled out in January 2005. This is just like totally hypothetical question, but the scenario that's been set up says that it was rolled out in January 2005. So the first part of the question asks you to write down a differences in differences estimate of the effect of this special blend on air pollution, and it gives you the option of basically writing it down either in a regression format or just in the actual like difference in differences formula. So the idea here is that you're going to use Nevada as a control state because Nevada doesn't have this special blend of gasoline, and you're going to look at how California changes relative to Nevada then, pre and post the rollout. So the pre-period is going to be 2004 and the post-period is 2005, and so if you wanted to just write it down as a diffs and diffs estimator itself, you could do the outcome in California. So basically, y is going to be like the average pollution level. So it's going to be the average pollution level in California in 2005 minus the 2004 level. So you're looking at the change in California, and then of course you have to subtract off the change in Nevada. So that's going to be the average pollution level in Nevada in 2005 minus the average pollution level in Nevada in 2004. So that would be sort of the simplest way to do it. But you should also know how to set it up as a regression to get the same estimate. Because in particular, if you want to sort of control for some other variables that you have in your data set, then in order to do that, you're going to have to set up as a regression. You can't really do it with just the simple diffs and diffs formula. So the regression specification that would be equivalent is that, so you're going to look at the pollution level in state I in period t, and the two things you always need to be controlling for in a diffs and diffs regression are, first of all, an indicator for whether or not you're in the treated state. So that's basically a California indicator or a Nevada indicator if you want to just kind of reverse it a little bit. But I would recommend doing a treated indicator, so you basically want a California indicator, and then you also need an indicator for whether or not the time period you're looking at is the treated time period. So that's going to be a 2005 indicator, basically. So you would have something like alpha, so y is equal to alpha plus beta 1 times an indicator for whether you're in California, plus beta 2 times an indicator for whether or not you're looking at year 2005, and then plus beta 3 that's either multiplied by an indicator for whether or not the special blend is being used in the period that you're looking at, or in the state you're looking at the same time period, or basically interaction between these two things. So you can either have like a special blend or like a treated policy indicator or something like that, or alternatively, if you wanted, you could make this an interaction between the 2005 indicator and the California indicator. So these two things are going to be equivalent because the special blend or the policy is only in effect in California in 2005. So when both of these things are equal to 1, then the interaction is equal to 1, and the policy is in effect in that state during that time period. And otherwise, one of these two things is going to be equal to 0, so the interaction will be equal to 0. So you could write it either with a special blend indicator or with this interaction term, and you get full credit. You mean like what coefficients or yeah? Yeah, no, that's fine. You can put whatever, you can call this whatever letter you want. They don't have to be Greek. They could be. It doesn't matter. Yeah, so this X is apparently permanently etched onto the board. That's why I tried to erase it, and then I was like, wait, that's not going to happen. So this is plus epsilon IT. This thing is, I can try to white it out or something, but it's not going to disappear. Okay, are we good now? Somebody must spend too much time on their hands at some point. So that's the first part. Oh, then the thing I should say is, if you had some other variables about these states that you wanted to control for, then you would have like a plus, so then you would have something like plus xit, gamma, or whatever coefficients you want to put on those variables, plus epsilon IT. So that's the advantage of setting up as a regression, is that you can put in some extra control variables. Question?
So is there anything in regression regarding Nevada? Is the data of California?
So yeah, so that's a good question. So beta 1 here, what it's doing is it's measuring the average pollution level in California relative to Nevada. So I mean, even though there isn't something that says Nevada in here, this indicator is really telling you like it's always relative to the omitted category, which in this case is Nevada. So it's implicitly in there.
Is the formula of that coefficient, is that the diffs and diffs, or?
Oh, sorry. So the diffs and diffs estimate there is going to be the beta 3 coefficient. It's the coefficient on essentially what you think of as being like the treatment indicator, which is like the special blend effect here.
So the three